Well, welcome everybody to Coffee with Caleffi, and thanks for tuning in today. This is Bob Hot Rod Rohr. I'm going to be your host today for the next hour, and I wanted to put together a presentation that fits the time of the season, which is fall. The heating season is just starting here in Missouri, so this is a time. And I tried to put something together that I think will apply both to contractors that are out there doing the work, as well as a building or a homeowner or system owner that might be watching you as you do the work. So hopefully there's something in this for everybody. So. Yeah, if you have questions as we're going along, just type them in there, and I'll try and get to them at the end. If there's something that comes up that pertains to a slide that I'm on, we'll try and answer it. Woody's up in Milwaukee going to monitor the questions for me, so if there's something that pertains to a slide I'm on, I'll try and answer it when we're there. But anyways, let's get rolling. So I put this Hydronics number 12 up there as a reference material. Now, we don't have anything specific to startups and that, but this has just really good basic information on hydronics, you know, about sizing pipes and pumps and heat emitters and boilers and stuff like that. So I think it's the one that probably comes closest to the topic we're on today. Now, with hydronics, if you're not getting them, you know, go to our website and sign up, and we'll mail these to you twice a year. We crank them out. So what we have so far for the hydronics is 1 through 15 got mailed out about 2 weeks ago. If you haven't seen that one in the mail, make sure you go to our website, and sometimes you get bumped off the list if you need to sign up again and make sure we keep mailing these to you. But quickly, what we did with number 15 is we wanted to revisit air and dirt and hydraulic separation again, which is basically what we did up there in the left-hand corner with issues number 1 and 2. But basically, since we introduced those, a lot of new products since those first 2 issues were published, we thought we'd just kind of go over the whole thing again, put it in the one issue. So we've updated the equipment in number 15, some of the new separators that we have with magnetic and stuff. So watch for that one. Again, if there's back issues that you want, let us know. If you're missing some of them or a couple of them walked away from your stash, let us know. And we've got everything but 1 and 2 are out of print, but anything else we can fill in your collection for if you want. So. And we also have a binder available. If you'd like to put them in a big spiral binder, let us know. We've got a bunch of those with the Caleffi name on it, so you can keep them on your shelf and keep track of them. As always, if there's a topic you think that we should be talking about or that we need to cover that we haven't yet, or something we need to recover because there's new product or something coming on, let us know, because we put these together fairly quickly. Like I say, twice a year we try and get one of these out. We're always looking for new and timely and good information to get out to you. I mean, we do these for you to kind of help the industry. They're good for everybody. So let us know what you think of what we've done in the past, and also what we can do for upcoming issues. All right, so pre-season checks and maintenance. I think the best way to start with a system is obtain knowledge. Know how to use all your tools, especially if you're going to be working in front of a customer or a client. If they're watching over your shoulders when you do this, it's good to know how to use all your equipment and stuff. There's a lot of information available. As I started putting this together, I realized a lot of the equipment I have is getting old and outdated because I haven't been out in the field for about 8 years now since I've worked for Caleffi. So as I started to go out and take pictures of some of my equipment and talk to contractors on the different trainings I've been out the past couple of weeks, I realized I need to update some of my equipment. So I do have some new equipment that I've updated. But what's interesting and what's helpful is that most of the manufacturers, be it a meter, a tool, a power tool, or something you buy, if you go to their website, they've got a lot of good training on how to use that product. I got a new RMS meter that I'll show you here in a couple slides, and I wasn't quite sure on some of the functions that my old meter didn't have, so I went there, and lo and behold, the manufacturer had a nice YouTube video that explained it, answered the question, the exact questions that I had on my mind. Well, how do I connect it? What's this new attachment do? So even if you don't have somebody locally that can, help you with equipment, explain how to use it and how to deal with it, you can go to their websites and usually get that information. And never stop. Like I say, this is an ongoing thing. There's new equipment, new products coming out all the time. Just try and keep as current as you can on all that information. You get to the job and make no assumptions, I guess. Confirm that the equipment has been sized properly. If you weren't the installer, if you're following somebody else or another service contractor who's worked on something before, just, look over what they've done and just make sure everything's right. And I would say probably the biggest thing you'll see out there if you're doing a lot of troubleshooting or service work is equipment that's been oversized, grossly oversized in some cases. If you walk into a house and it's a 15,000 square foot house and you see, a boiler that's 3 boilers there at 1 million BTUs or something like that, there could be that somebody's oversized the equipment or undersized it. So in some cases it's wise to do a heat load calculation on the building just to prove to the owner, well, you've made upgrades to this home over the years and now your heat load's reduced, so it's time to maybe look at sizing down this equipment. So everything. The gas line, I know some of the people that put in tankless type of water heaters or boilers, sometimes they require bigger gas line sizing than what the previous equipment would have. That can cause a problem, especially on the newer equipment that have like negative pressure gas valves. They're very sensitive to having enough gas line going to them. And of course, pump sizing. Pump sizing, we're going to talk about that in December and January. John Siegenthaler is going to lead 2 sessions for us about you walk into a job and there's a pump on it. Is it the right size? Where's that pump working on its curve and stuff like that? So we're going to address that one a little bit more specifically in a couple more webinars. But I see that as the second most common thing on a job when I walk in. Either the boiler's been oversized and the pumps. You know, people have changed brands or changed pumps over the years and just probably put in whatever they had with them that day or was on the truck. So they could be running way off or way to the top, to the bottom of their curve, who knows. But we'll show you a little bit about how to use sizing information from the manufacturers and put a system curve over a pump curve and determining the operating point on that curve. So stay tuned for that towards the end of the year. And then look for evidence of past problems. A lot of times you go on the jobs, if you see a half a dozen expansion tanks laying in the corner of the room, you can assume that probably you've got an issue with maybe oxygen getting in the system, that there's pinholes in those tanks. There's a history of that problem. You might be the guy that says, you know, there's a better way to do this instead of replacing the tank every couple of years. Let's address what's causing that. And same thing with switches that might have been disconnected. I know when we did a lot of copper tube boiler, there'd be issues with the flame rolling out the front sometimes, and a service contractor that didn't understand what the true problem was tended to just disconnect or hotwire over the top of safety switches. So, again, just pay attention to what's been done in the past. Maintenance logs, if there isn't one there when you get there, that's a good thing to leave when you leave the job. Just sometimes a piece of paper with notes on what you did, the date that you did it, and stuff like that. It'll just maybe help you or the next person that works on that job. So it's good to be there with the building owner, the owner of the system, because then you can ask them questions, you know, the past history. You know, have you had problems with this since you've been here? Does it keep up, you know, when it's cold outside? Does it keep up with the heat load? Fuel costs, are they realistic? Is that what you think they should be doing? This is a good time to suggest improvements, you know, pump sizing or boiler changes or stuff like that. And then again, I can't stress enough keeping some kind of documentation on the job. Sometimes what I would do on the front, right on the front cover of the boiler, I'd just take one of those small Sharpie things and just make notes right on there, the date that I was there and what I did, especially if I'm checking glycol and stuff like that, that, you know, somebody wants to keep an eye on that yearly to see if the pH range or something's dropping, you know they've got a problem coming up. Tools. This is a meter I just got. This is a new True RMS meter, and what I found is that when I started working on some of our solar controllers and some of our equipment that has electronic components in it, microprocessors and stuff, or variable speed drives, you can't read that accurately with the typical meter that you're used to. So if you're working on electronic equipment, variable speed drives, anything that has resistors or triacs in it, you really need to have a True RMS meter. And again, this is the case where I went to the UEI website and I took a little training course. They had their little YouTube video and explains a little bit more, you know, what type of equipment, and it actually shows what kind of errors you could have using a traditional analog type of meter compared to a True RMS meter. You know, it can be as much as a 40% error in the readings. It'll still read the voltage and stuff, but it can be way off and it can fool you. So if you're working on new equipment with electronic components on it, you might want to upgrade to a new meter. There's meters for everything, and what's nice about the meters now, that meter that's I've shown there on the side, that little UEI that I just got, it has a lot of different attachments for it, so you don't need to have a lot of different meters because that can do a lot of different things. It can do amp readings, it can do temperature readings. It's got a little hook, like you can see there, we can just hook it right over the connection going to a zone valve and read the current draw on that. Data loggers and stuff are available for some of them. When I talked to the UEI people, I said, you know, it's time for me to upgrade a meter, which I look at, and he said, really, this type of clamp-on stick meter, he said, is the meter that most people are using now. There's really no need to have a multi-type of meter because this type of meter with the attachments, the heads that plug on and off, it can do so much more, so you don't have to have a whole bag full of different meters. This one meter covers a lot of different applications. Combustion analyzers, this is a must, especially with the high-efficiency equipment that we're putting in today. In fact, most of the boilers that you have, you'll see right in the installation manuals on these ModCom boilers that they want you to set it up with a combustion analyzer to make sure that from day one that it's adjusted to the conditions on your job site, to the fuel that's on your job site, and to the the conditions on the actual installation. So that's one that you're going to need a little bit of training on. If you don't own one or you haven't owned a combustion analyzer for a while, I would certainly you know, if you can take a class at a trade show, or again, go online and take one of their online classes and learn how to use that, because that's a very important part of getting high efficiency equipment dialed in, so you don't have ongoing problems with them sitting up or going into lockout and stuff. Balancing gauges, you know, if you're working on commercial applications where you see a lot of flow setters that have been installed in the building, you might want to consider a delta P type of meter. They can go around and make sure that those have been set up right, or confirm that if there's been changes made in the distribution system that somebody's gone back and readjusted those. There's digital versions out now. There's the round analog types. You can borrow those sometimes from a rep or one of the wholesalers. Sometimes they'll have a gauge like that if you don't use it a lot, but you want to go out and check a commercial job that has a lot of flow setters. Possibly you can just borrow somebody's gauge for the day. Fluid testing. In the last couple months, I've been doing a lot of traveling. I was back east all last week, and there's a lot of concern about fluid testing. I think the time has come that with these little high-efficiency boilers with small tube heat exchangers, if there's issues out there with those overheating or starting to fail or starting to get pinholes, most of the time it's going to be related to the fluid that's going through them, whether it's just water, if it's glycol. So I'll show you some pictures coming up here of some of the equipment that you can buy. Not expensive equipment, meters that you can use to test not only glycol-filled systems, but systems that have just basic tap water and water that's been filled in the system from the job. Or if somebody's put inhibitors in it over the years, there's little test kits that you can get for that. Spindicator is another little handy tool that you might see as little giveaways out there. I'll show you how to use those in a minute. I was talking to one of my contractor buddies this week and said, well, you know, what are you using for equipment these days? What do you got going on for your combustion analyzers? And this is a picture of the meter that he uses. And what was interesting is he's got the Bluetooth module for it. So when I had the backwrap meter that I've used for years, had a little thermal printer that came with it. So every time I would leave a job, I would leave a copy of the report from the combustion analyzer on the job site, write in a little envelope with the boiler, and then take a copy with me. So if down the road somebody said, well, that boiler was never set up right, blah, 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 I had a record of it. You know, it was dated on there, had date stamp and everything on it. He said, well, that's, you know, he said, that's old technology. He said, now he's got one that can just send him an email with all that information so he can have a copy of that, put it up in the cloud, or keep it somewhere where it's safe. So he's got a history of what he's done on these jobs. So, again, the technology's changed since the little battery-powered thermal printers, but a lot of good equipment out there. I'm not trying to, you know, sell you one brand here. So if you're looking to upgrade or looking for some new equipment, shop around. There's some great equipment out there. The prices have come down quite a bit, too. I think I paid about a third of what I did for my last digital meter on that new RMS meter that I just got. So, and thanks to Kurt for that information, by the way. This is a little spindicator. You see these little giveaways. Sometimes the pump people have been giving them away. You see some of the brands there on the left-hand side. Basically, when the pump people give them away, they say, well, you set this on the end of the pump, and it'll tell you if the pump is running. Well, that may or may not be true, because basically what this does is it reads a magnetic field in there. So if you put this at the end of the pump, what happens is that little dial on the left-hand side of the spindicator, let me see if I can point to that, will start spinning. But it'll also start spinning if the pump is not spinning. So in other words, if you have a pump that's seized up, it's got bad water quality or something that's seized, or you've got a pump where the shaft is broken off, so the motor's spinning but the impeller isn't, this thing will be spinning, and it can fool you. So to me, really, it almost just tells you that there's voltage going to the pump. It is handy for other things. You can put this on the end of a solenoid valve and see if that's been powered up. So you can see up there on the top, it shows you some of the applications. Now, it doesn't work on all the pumps. It doesn't work on the new ECM pumps that I've tried it on. And some of the brands out there, different brands of pumps, it doesn't work on at all. So even the old style permanent split capacitor motors. Another thing I found it was good for, if you're taking a sample of your water, one of the things that we're concerned about now, especially with ECM types of pump, is that we don't have a lot of this fine iron ferrite, this tiny magnetic particles that can stick inside the system. So if you take a sample of the fluid out, put it in a little glass or plastic cup or something like that, and you can take a little spindicator and it'll tell you if you've got a magnetic particle in there. And that you're going to see if you've got systems out there that have non-barrier tube, the old polybutylene systems, or maybe some of the early rubber tube systems that didn't have oxygen barriers in them, you'll get a buildup of this iron ferrite in there, and it looks like a little, almost like a talcum powder consistency of magnetic particles. If it sticks to a magnet, guess what? It's part of your system that's being dissolved, and it can settle out in tubes, it can settle out in heat exchangers and cause a problem. So use your spindicator to test your fluid sample too. Gauges. Probably my biggest pet peeve of all the years I've worked on equipment is the gauge that comes with a lot of the boilers, the tridicator gauges they call them, where they read not only pressure in the boiler, but they'll tell you the temperature in the boiler. Some of them will have a little dial in there that gives you the altitude of the fill water, hence the name tridicator for 3 different functions. They're not always the best quality. I would advise you to get a good quality gauge, and it's worth spending a little extra money on that. And the gauge I like is this one down here on the bottom, and it's a glycerin-filled gauge, so it's a little higher quality. You can buy gauges from little, what they call utility, kind of I'd consider a throwaway gauge that you use a couple times, and they fall apart. And then you can get middle-of-the-road gauges, and you can get high quality and get all the way up to lab-quality gauges. But this is a good middle-of-the-road gauge. It's a stainless steel case, and it's glycerin filled. I don't know if you can see the fluid level in there. So what that does for you is, number one, if you're reading something like a pump output or something like that, and it's got a little bit of vibration or bounce to it, the needle won't be bouncing around in there because the fluid kind of dampens it. And the other thing does, it keeps the needle safe in there. So if this is bouncing around in your truck or your toolbox and stuff, you'll see a lot of the inexpensive gauges. Sometimes you go to use them, and the needle is falling right off the stem on the end because it can't handle that harsh abuse. So this one looks like it has a little snubber on the bottom of it also, but and not super expensive. I would say a gauge like this is probably about $30 compared to a $10 or $15 gauge. Now you can buy them with this little extra needle in there, and it's sometimes called a lazy hand or a follower needle or a telltale gauge. So basically what happens when the pressure goes up, it pushes this needle along with it. So if you want to leave this on a job for a day where you think you're getting pressure spikes in a system, or you're wondering that the pressure is changing when you leave there, you can put this on, of course, turn this little knob here. It'll bring the red hand back down to this hand, and they'll move together. So I keep one like this on my truck, and this is a little cheesy gauge here. Not a slam on the company, but as far as the quality of the gauge. But this here, I have it with a hose connection. So I use this, as you can see, it's a high-pressure gauge. So I'll put that on a house where they're having problems with high pressure conditions, maybe faucet washers are going or toilet ball cocks are going out of the system. You can put this on there, and what you'll find sometimes is you'll go back and you'll see a spike in the pressure where you leave it on the house, it might have 50 pounds when you leave. You come back a couple of days later, it's bounced up to 120 or 150 pounds, which could indicate that there's a bad pressure reducing valve somewhere on the city system, and it's good to notify them if you see the house pressure varying that much, or possibly it's a house that doesn't have a pressure reducing valve installed. But for boiler work, for hydronic work, I would get a gauge like this with a 30-pound gauge, so it's accurate. The resolution's a little bit better than the pressure gauge that goes up. Certainly you don't need a 200-pound gauge on your boiler work, but get a 30-pound glycerin-filled gauge with this little follower hand, and that should last you for years. It'll be accurate. And, you can put a connection like this on, because what you could do with that gauge is then most boilers have a drain cock on them somewhere. You've got some sort of hose connection. You can screw it right onto that hose connection and open up and see what the pressure is and compare it to the gauge that might be on the system. So that's a little tip for you. Some of the tools that you can use for sizing information, we talked about, sizing, making sure the equipment on the job, the boiler, the pumps, the pipes, everything on the job. This is a program that I use, a little design program from John Siegenthaler. You can look at this at hydronicpros.com. There's a little demo out there that you can play around with, but it'll do a lot of the sizing information. There's information in here for sizing pipe size, expansion tank sizing, make sure they've got the right tank installed there. If you see a pressure relief valve that's been popping off, there's a chance that the tank has been undersized, or when it was replaced, they didn't put the proper size on there. So all these different toolbars across the top here can be used for troubleshooting as well as for new calculations, heat load calculators, if you want to check and confirm the load calculations for the equipment that's on the job. So it's not just for designing new work or for new installation jobs. That can also be used for troubleshooting. Keep it right on your laptop. Keep it with you when you're on the job. So if you're looking at all these things and you want to confirm things, just pull it out. You can run through the different modules across the top and do a lot of on-site calculations. Fill valves, this is one that you're going to come across probably most often on the troubleshooting call. And one of the things that can happen with a fill valve, if they don't get used for a period of time and then you go there and you take some fluid out of the boiler to check the fluid quality, or you change a pump, or you do some work on it, you've got to refill the system. One or two things can happen with these valves is either they'll stick shut where they won't refill. When you go to use them again, you drain some water out and you turn that valve on, you tap on it trying to get it to fill, And the opposite thing can happen. They'll fill up and they'll keep overfilling because that little seat in there, if it hasn't been used for a while, with a little rubber washer, little diaphragm that comes down on the seat, sometimes it'll get stuck, and then when it opens, it'll rip it or put a little tear in the washer, just like when a faucet washer goes bad. So this is a valve that you might find yourself replacing quite a bit. I like to think the Caleffi's got a really good quality one. We do have a valve that you can take apart easily here that you can get in there, and if there is some debris that's stuck in there that's causing it to overfill, you can service it. It also has a strainer around the whole entire body here, so any dirt and debris that's coming from the system, maybe galvanized pipe or something coming into the system here, that dirt and debris can get into your fill valve. So that's one I would probably keep a spare on your truck. Just plan on replacing some of them when you go to use them if they haven't been used for years. Another case where a good quality gauge on it can help you make sure that you're getting the accurate fill pressure in the boiler. And you can see on this is our 3/4 inch, our fast fill valve. It'll fill about 9 gallons a minute, and it's got a gauge on it also. Fluid quality. This thing comes up a lot, and it's coming up more and more often. I don't think a lot of people realize what's going on with the system fluid and how critical it is to not only the heat exchange ability of the thing. If you've got a buildup of lime scale or calcium that's built up inside your heat exchanger, you know, the efficiency of that device is really starting to drop, and it doesn't take much. I mean, we're talking a millimeter or two thickness can really start changing the heat transferability of a heat exchanger, and that's true in the boiler as well as the heat emitters. If you've got panel radiators or something out there that are getting some kind of buildup of scale on them, they're not going to give the heat off that they would if they're a clean surface. So you want to test it. Now, glycol systems, there's a couple different tests that you want to do with that. You want to make sure that the glycol percentage, the freeze percentage is right, so you don't have problems with cold weather and the power going out and freezing something. So you want to use like a refractometer for that you can just put a little drop of it on there and just look down through it and see what the freeze protection is. And the other one that's critical is a little pH meter, because as glycol goes bad, what will happen is the pH will start dropping. Typically when you put new glycol in a system, it'll have a pH of about 10.5 to 11.5. If for some reason there's conditions in the system that the inhibitors in that glycol are getting used up, it's going to show up as a decrease in pH. So as you go back there every year, every couple of years, you take a sample and you notice, well, gosh, now it's at 9 pH. I go back 2 years later, it's down around 8 pH. If it keeps dropping, there's a good chance you've got oxygen getting into that system, or the glycol's been overheated and stressed. And you'll see that more in solar systems where you can go into stagnation conditions and the pH gets overheated and the inhibitors break down and then the pH drops. And, of course, once the pH drops, you can get a condition like this little vent over to the side here where it gets pretty aggressive to different things. You can see that, obviously, that vent's leaking out of the cap. Something got stuck under there, and now the fluid's coming out. But you can see it's kind of attacking that brass in there. So there's probably something pretty aggressive in that fluid, and I would bet that's probably a glycol that's been compromised, and the pH is dropping, and it's gotten the attacking some of the brass and copper components in there. Now, basic tap water, I'd say a lot of the jobs that you fill with the water that's available on the job, if it's city water from a city system or from a well system, probably hardness is one of the biggest numbers that you want to know there. TDS, total dissolved solids, there are little stick meters I'll show you that you can buy for that, not very expensive. I would check that if you're doing a new job, filling it up for the first time, and see how hard the water is. And this is a very inexpensive, simple test kit for checking the hardness. And I would say if it's over about 12 grains hard, I would consider either getting, bringing some water in from another source that's a better quality water, or maybe getting a little deionized machine that you can put on the fill water and just fill through that to make sure that you've scrubbed some of that hardness out. You'll notice most of the boiler manufacturers now are putting that right in their installation information right now. They're going to put a water quality, and it'll tell you the hardness that's acceptable, the TDS, the pH of the water, chlorides, especially if you're using stainless steel boilers or stainless steel coils in your indirect tanks. The chloride level is pretty critical to that. So I think I've got a slide coming up. I'll pull some of the installation information from various different boiler manufacturers to see what they're saying about the water quality, because they can refuse a warranty if you have issue with equipment and that water wasn't maintained or put in with the right spec on it. Now, if you have a problem job where you're having issues with that, you can send a lab a sample of the water, and they can do a more thorough analysis than you can do with some of these little stick meters that I'm going to show you coming up. Sometimes the chemical suppliers will do that for you. If you are filling your systems with inhibitors or with glycols, whatever manufacturer that you're buying that from, or whatever manufacturer's on the label, if you buy that from a wholesaler, check with them. And lots of times they'll ask you to. Sometimes they'll even give you a little sample jar to take out to the job and put a sample in, and they can do a little bit more of a analysis than you would probably be able to do just on the job site. Universities, sometimes the local colleges will have a department that can do water analysis, especially fill water, if it's city water, something like that. The best gauges that I've found to use for this here are these little electronic stick meters, I call them, and they look something like this. And not very expensive, as you can see here. Probably every meter on this page, you'd do, what, maybe $300 to buy all of these. This one's kind of handy. Again, electronic meter, so all you do is stick this little probe into the sample jar. Got to get it immersed all the way down to this level here, and this one here will read the pH as well as TDS. It'll tell you what's in the fill water. Change the batteries. You can recalibrate those every now and then. You can either send them back to the manufacturer, or you can get a fluid sample that you can stick them in that's a known pH level, and that you can recalibrate this. Most of them have little spots on the back where you can change the calibration on them, or take them to a lab or something like that where they have water at different pH levels, and they can readjust that for you. For testing glycols, I like this. It's called a refractometer. It's a very simple thing to use. You just put a little drop or two of the glycol here. You close this little trap door on here, and when you close that and you push down on this with your finger, it actually turns a light on inside here, and then you look down through the end of this like you're looking down through a scope or a sight glass, and then you can read most of them will read both ethylene and propylene glycol. On one side will be PG, on the other side will be ethylene glycol, EG. And they'll tell you the freeze protection rate. I like it a little bit better than those floating ball types. It just seems to give you a more accurate number, and it's a lifelong tool as long as you keep this thing protected in your truck. I've had mine for probably 20 years now. And the same thing, you can take this into a lab or something like that and make sure that it's reading accurately. This one here, a hardness test kit. If you've ever worked around water softeners or something like that, you're probably familiar with this type of kit and this brand name. Basically, all you do is you just take a sample water in the jar, then you put these different drops in there, and you watch until it changes color. So it's going to tell you the grains of hardness of the water. So inexpensive, simple kits to use, but really critical to make sure that you're protecting the owner's investment as far as the quality of the fluid in there. Now, if you are going to start using inhibitors, and think maybe I've got that on the next page. If you're going to start using different corrosion inhibitors or different hydronic system inhibitors, you'll have to get a test kit from the manufacturer that can test that. And sometimes there are little jars that work similar to that hardness test kit. Some of them have little electric meters that you can put in there, because it's going to be a meter that's going to test specifically the ingredients or the inhibitors that they're putting in that fluid. And there's a lot of different types of inhibitors that have been used over the years for conditioning hydronic systems. So make sure that the kit that you're using matches the fluid that's in there. You're going to get some kind of crazy readings. Some of the guys, especially guys that are doing geo work and that are putting a lot of fluid in systems and want to make sure they're protecting the heat exchangers and those geos and heat pumps and stuff like that, are filling with deionized or demineralized water. It's sometimes called DI or DM water. And what you can do is you can actually rent or buy this type of equipment, and it looks a little bit like a softener tank, although it doesn't use salt, it doesn't backwash. So there's a resin, a media inside this tank, and so you can see right here he's got the water coming in from his water, just a hose connection somewhere in the building, in the house, going through this tank, and then out the other side he's going to hook to a system that he's filling with. So this one has a little light on it, and that's basically, it's just a conductivity meter. It's just a TDS meter, and so it's going to tell you when this thing needs to be rebed. And the other thing you'll notice about these lights, if you're flowing the water through there too quickly, the light will come on and tell you got to slow down, that the size of the canister can't treat the water as fast as you're flowing it through there. So it has two purposes. It'll tell you when it's time to rebed, as well as that you're flowing through there too fast and it's not doing a good job. So in my area, Culligan has these available. You can rent these or lease these on a yearly basis or per job basis. There's different sizes of them depending on how many gallons of water that you want to run through it before it might need to be rebedded. And you have to take these back, and they basically just take this top off and they dump it out and they put a new resin in there. Some of the resins can be reused. They can clean them and reuse them, but most of the times you'll see they'll dump them out and rebed them for you. We did a really good coffee with Caleffi here a year ago. It was actually February 2013. Jeff Persons is a geo installer in Ohio, and he did a really good one on fluid quality and its consequences. Again, he's a geo installer, but he does do boiler work also, so he had a lot of really good information about testing water and some of the ramifications when water starts to go bad, some really practical information. That is on our archive, by the way, so if you go to Caleffi.us and you just click on the Coffee with Caleffi, you'll see an archive button there, and it'll come up as a little YouTube type of video. Over here on the lower right-hand side, this is actually a heat exchanger that I cut apart that I took out on my own house here. It was one of the little ModCon boiler type of heat exchangers, a circular type of heat exchanger. And when I put that in, I did put a cleaner, and then I put a corrosion inhibitor. I happen to use the Rohr brand, which they call Protect 955, or 922, sorry. The other one's a cleaner. And basically, one of the ingredients in these corrosion inhibitors is a film provider. And so when I cut this apart, I took my hacksaw, and after I cut the tube out of there, I cut a little window out of it so I could see inside there. And you can see I took my knife and I scratched it off after I cut it open, and that's the little film that the provider, that's one of the ingredients in the corrosion inhibitor, actually put on the bare stainless steel tube. So instead of just having bare stainless or bare copper, whatever the metal the heat exchanger is made out of, it puts a very, very thin film. It's almost like if you take a little skin off your thumb or something like that when you nick your thumb, it's that thin of a layer on there. So it doesn't hamper the heat exchange efficiency, but it does protect that metal from being attacked. So if you do have water that has a pH that's out of whack, it won't start going after that metal because it's got a little layer of protection on it. So that's what you want to find. And there's a lot of good brands out there. Fernox is a brand that has both the cleaners as well as the different inhibitors, Rohr and Sentinel. And they also all have test kits available that matches the fluid, so you can go back and test sometimes you have to boost the inhibitor. If the inhibitor is being used up and you have to boost it, it's saying that there's got something going on in the system. Most of the time you've got oxygen getting in there that's using up or compromising those inhibitors. Another tool that might be handy is one of these fill and flush carts. Now we build up a bunch of these for guys that were doing solar work. You just dump your glycol here and then you could pump it in there. But it can also be used for purging or cleaning systems. You could put a cleaning compound in here and just run it through there. It's got a pump that'll pump about 80 to 90 pounds pressure, so you can get a good scrubbing action going through the different loops and that. So there's other brands out there. I know some of the companies that sell tankless type water heaters have kits available now for flushing them out. You just put a mild acid cleaner in there. It's got 2 hose connections connected to the tankless heater and run it through there, and you can scrub out any buildup that's inside there. But we can help you with that if you're looking for a purge cart like this that can be multifunctional, that you can use for filling solar systems or filling snowmelt systems where you want to put glycol in it. Or if you have a system that's plugged up or that you want to clean out, it can be used for that also. Magnetic separation. This is becoming more and more important. We do a good job with most of the different type of separation and filters that are out there now, and Y strainers are getting big dirt chunks and debris out. But these fine little particles that can be coming out of a system that does have non-barrier tubing in it, a magnetic type of separator will get a lot more of that fine particle out than you can with just the media that's inside there. And here's a couple examples of the products that we offer from Caleffi. This is what we call our combination air and dirt with a magnetic band on it. Basically what you do is you come back to this job, and I like to put a cup or a white 5-gallon bucket under here and just open this valve here and just blow down. You got to take the magnet off, give it a second or two for the particles to settle to the bottom of the cup here, like you see in the middle picture, and then you can just blast it out the bottom here. And this is another reason why you want to have a fill valve, that if you're going to start taking water out of here, especially if you're going to take a gallon or more out, you need to put water in behind it, so you want to make sure that your fill valve is going to kick on and that it's not going to stick on. But go back and take a sample. If you see this coming out year after year, every time you go back there, it's going to be a problem. It's dissolving something in your system. Most of the time it'll present itself as pinholes in the expansion tank, but it can be also eating away in your pump volutes, or if you've got a cast iron boiler or any ferrous components, it'll start eating away on that. And there's an example. This is one I've got on my wood boiler at home, and every year I just take a little glass or plastic cup on there, blow it down, and see what kind of particles are coming out of it. So shop around for a good magnetic protection device next system. We talked about expansion tanks. I know Jody covered this last month. If you didn't tune in last Coffee with Caleffi, Jody did a great job on a webinar all about expansion tank sizings, how different ones are built, how to troubleshoot them and stuff like that. So I'll just kind of recap some of the things he talked about. And, of course, sizing it correctly is important. This is a cutaway of a typical what we call a diaphragm tank, and the way this works is you can see there's a little a Schrader valve at the top that you put the air charge in there, and then there's a bladder, and it's basically crimped. You can see this one little connection right here, so this little membrane is crimped in there, so there's air on one side and, of course, the fluid on the other, and it pushes up and down. And he went over quite a bit of this. I mean, there's what we call an acceptance in the tank volume, and the reason for that is you can't stretch this diaphragm completely to one end. So even though this tank might hold 4 gallons of fluid, it might say it's a 4-gallon expansion tank, the acceptance of that might only be 2 or 2.3 gallons because you can't stretch that in there. So I thought having a little cutaway kind of shows you a little better what's going on inside that tank. Now, what can happen on these is this is just a Schrader valve, just like a tire stem that you have on your car, and they do leak, just like you can lose air out of your tires on your car, your truck, or your lawnmower, whatever it might be. So this cap that comes with them really needs to be on there to give you a second seal on that Schrader valve. So if this is gone when you get to the job, then keep some of these with you, or just take one off the tires on your truck and put it on there, because they can lose pressure over the years through this little Schrader valve. Now, the other thing, keep in mind, if you're going to test this tank to see if there's an air charge, what the air charge in is, number one, you've got to isolate this tank from the system and bleed the pressure off it, so you're reading the pressure in the tank, not the system pressure. But keep in mind that every time you put a gauge on there, year after year, every time you go back and check it, you're going to let a little bit of air out of this pre-charge. You do that, so at some point you might have to take your little hand pump of your compressor back and repressurize this tank because you've let some air out of it. Another thing that happens with tanks, if you do get a little rip in this membrane or a pinhole or something like that, or a braze where it's been sliding up and down there, then you're going to get what's called a waterlogged tank, so the water's going to just fill up this whole capacity. If you just shake or wrap it with your knuckles, you can tell if you've got a tank that's been waterlogged, and of course that needs to be replaced. Another way to see if your tank's been waterlogged is fire the boiler up and see what the pressure gauge does. If the pressure gauge starts jumping up quickly as soon as the fire and the expansion of the fluid goes up, a good chance that you've either got a bad tank or you've got one where the air charge has been lost in it. And the other thing to look for, if you see that the relief valve's been popping off, you see a little stain on the floor with the pressure relief valve on the boiler, that's another indication that you've got a tank that's, number one, either waterlogged or it's undersized, or it's lost some of its air pressure charge and you don't have enough expansion capacity in it. There are a lot of nice isolation valves. If you're going to put an isolation valve on here, it's a good idea to get with one that's called a lock shield, that you can lock it in the on position so that a homeowner or somebody might come and say, oh, that valve should be in the off position, and inadvertently turn the valve off, and then you've taken this out of the system, and now you're going to have a discharge on your relief valve when the boiler heats up. So most of the valves that are out there now that are made for isolating expansion tanks have a side port that you can drain the pressure off. You can take a fluid sample out, and they'll also have a means that you can lock the handle in the position, open position. Some guys will just take a crescent wrench and take the handle off and put it somewhere else on the job, so somebody's not tempted to turn that valve off and isolate the expansion tank from the system. I know Webstone, I think Taco, there's a lot of brands of Watts, I think, has a nice expansion tank isolation valve out there also. Pressure relief valves, a couple things to keep in mind. There are ratings on pressure relief valves. When you go to a job, make sure that the right valve is in there. You don't know that the last person that might have worked on that or even installed that valve didn't put the right one in. Critical, of course, is the pressure on it, but also the capacity of this valve. You can see in thousands of BTUs per hour. If you've got big commercial systems, make sure you've got a valve big enough to handle the capacity of that system. So these do come in different sizes. They do come in different pressure ratings, and they do come in different capacities down here. So that tag should be on there somewhere, and it's going to tell you what that valve is capable of doing. I prefer this type of valve. This has a brass body in it. There are some out there that have steel or iron bodies on them that can get a little bit of rust and corrosion in them. I like the brass type better. Now, the controversy on this type of valve, when you're doing your startup check, some guys say, well, you should pop that valve to make sure that it's not stuck, so that there is an overpressurizing condition that this valve can relieve and do what it's supposed to do. Keep in mind, if you pop this valve, there's a chance that the valve's not going to seal again after you release the handle, because you'll get, again, you can rip that little diaphragm or that little washer that's in there if you pop one that's been stuck for a while, and then they're going to seep through there, and then you're going to have a drip. So if you are going to go around and pop these valves when you do a check, and I know this happens a lot when like home inspectors go around and they do a home inspection on a boiler or something like that, and they say, oh, yeah, my checklist says to pop the relief valve on the water heater on the boiler. and then they drip from that day forward. So if you're going to do that on a check, I would make sure that you've got a valve with you to replace it. Make sure you've got the right size and the right capacity. So if that valve doesn't seal again after you pop it, you've got one that you can replace it quickly. Put a discharge tube on that is the other thing I would say. I can't tell you how many times I've been a job where one of these is on top or on the side of a boiler, and it's just going to blow out all over the room if it discharges. There's a threaded connection there, and you should take that down within 6 inches of the floor so that if it does pop and discharge, it's going to go down to the floor, down to a floor drain. Okay, I think I got all that. System and documentation, I talked about this a little bit earlier. I mean, you can do it on your laptop or your computer, your tablet, whatever you're taking around these days for your communication. You can do it on your phone. Documentation, not only as far as taking pictures of it, take pictures of the jobs when you're done or when you get there to show the customer what, the before and after pictures, but also maybe a little wiring or a piping schematic. You can just draw that. I've got notes, and I've got another one on my phone and on my iPad that's called Scribble, and you can just take your finger and you can draw, a little schematic or a little piping diagram and take it home and maybe clean it up a little bit. But it's really easy to do when you're on the job site because you get in your truck and you're driving home and you're trying to remember what that looked like, or the next time you get a service call from that customer, it's good to have a trail and a picture of what that job looks like or what you might have done when you're there. Again, another case of a pump that came out of a system. You can see some of the solder there that, when they soldered some of the joints in there, they had some of the solder laying inside the fitting, and of course it worked its way through the system. It got inside the impeller here, which obviously is going to change the performance of that pump. And in some cases, if you get a glob of solder, some kind of dirt on one side of the impeller like that, it's going to throw them out of balance, and they'll shake and they'll vibrate, and they're not going to last very long. They'll start wearing on this wear ring and stuff like that. So I can't stress how important it is to have a good dirt separator in your system, whether it's a brand new system you're putting in or a system that you're going to do some retrofit or a service call. This is another version that we make. This is nice that you can turn this. You loosen this nut here, and you can turn this and use it as a vertical or a horizontal application, and it's also got the magnetic band on it. So that's one of many different versions that are out there, but it's going to just protect all the components in the system, not only the pump, but zone valves, balancing valves, heat exchangers. Another handy gauge you put on a system is a flow meter that'll tell you. You can just we've got a little 132 flow meter that you can just pull a ring and you can see what this pump is doing. So if you know your system needs 10 gallons a minute through it, if you've got a flow meter or a flow setter somewhere on the job, you can just confirm that's in fact what's going on. You can do it with pressure gauges. We're going to show you how to do that in the webinar that we're going to do in December with John Siegenthaler. He's going to show you how to check pump performance with pressure gauges as well as flow meters and stuff like that. Again, without a load calc and knowing the original design on it, there may be some guesswork involved in pump sizing. You go to a job, there's no documentation. All the pipes are, of course, closed up in the wall. You can't see what's going on. You don't have the heat load calculation. So that's another thing we're going to talk about in the webinar in December is how to tell that the pump that you've got in there, what it's doing, how to build a system curve and analyze if it's the right pump and what you can do to correct or change that. Boilers are what they breathe. This was a sealed combustion boiler, believe it or not. So all the intake air was coming from outside, and the exhaust was going outside. It was vented both the intake air and the discharge air. But they were sheetrocking in the house, and this is all the dust that had sucked in through the louvers on the side of the cabinet. So this little microprocessor-controlled fan inducer, which is for the gas valve here, was just, you can see the whole printed circuit board was covered with dust. This had to be replaced. So pay attention to those things too. It doesn't specifically have to do with the fluid or the hydronic side of the system, but certainly that's not something you want to fail in the middle of the winter time, especially if you don't have another one along with you. So look inside the boiler, take covers off on blower motors and stuff like that. See if there's any dirt and debris that you can blow out of there with an air hose or something when you're there. I talked about combustion analyzers a little bit before. Again, a lot of different brands out there, a lot of good brands out there. Places you can go to get hands-on training whenever there's an expo or a trade association. There's supply houses maybe having a little expo or something going on. You can talk with the manufacturers that have booths set up. Sometimes they'll have a little training set up. Supply houses, sometimes they'll bring in an expert from one of these companies and do a little demo and do some training. Again, a lot of things online, YouTube videos and stuff like that. One thing I would caution about YouTube videos is I would stick with one that's been produced by the manufacturer. I've seen some pretty crazy stuff out there that people do in their backyard thinking they know that they're an expert on the topic, and I'm thinking, oh my gosh. So I would go to the horse's mouth for that kind of training. Don't go to just your neighbor and ask him what he does. And again, at the different trade shows, usually at the ASHRAE show, at the Comfort Tech show, some of these companies that do this type of training specifically will be set up there, and they'll have courses available for you. Or again, they can courses that you can do online also. Another issue that often gets overlooked is return temperature protection on boilers. And here's an example of a copper tube boiler that's been corroded pretty badly. And you can see some of these big particles that have dropped down, or some of the B vent that's corroded because this boiler's been running in a condensing mode for extended periods of time. Now, years ago when these boilers came out, we were told that they could handle low return temperatures for periods of time. That didn't exactly prove to be true. If this type of boiler was connected to a low mass, low water content system, this type of protection wasn't as critical because they could get up to temperature quickly. And I'm talking about, you know, a system maybe thin tube, copper tube, baseboard heat. Doesn't hold a lot of water. It's got a very low mass to it, so it can heat up quickly. So this boiler can get out of condensing mode within the first 10 minutes that it fires up. If you're going to be working with radiant systems, especially radiant systems that are in slabs, concrete slabs, they've got the ability to keep a boiler down in the condensing mode for extended run periods, and that's going to be a problem. Unless the boiler is specifically designed for that, like a condensing boiler that likes to have cold return temperatures and scrub some of that additional heat out of the flue stream, you want to have some sort of protection device. Another thing that I'm seeing more and more of is guys are adding buffer tanks to systems, especially systems that have a lot of small zones on them, and they're doing that even with condensing boilers to keep them from short cycling, to make sure that they come on. They've got a nice, you know, at least 10, 15-minute run cycle every time they kick on, so they might go back and add a buffer tank. That's a good time to look at putting one of these little return protection mixing valves on it. This is just a fixed temperature valve that you put right in the piping like this. So basically what it does, it allows the water to bypass back to the boiler until this temperature is to the point that it's going to prevent this boiler from condensing. Usually this will be set around 130 degrees to make sure that this boiler always sees 130 degrees here. Once that temperature is satisfied there, then of course it'll allow this port to open and go out to your buffer tank, your system, or something like that. We at Caleffi offer a couple versions of that, just a basic valve like this that you can pipe in with your own pump, and we have them with a pump built into it. The other place that this is critical is a lot of guys are starting to look at wood or biomass boilers as a backup to their, or as a first source of heat if they're on oil heat, or propane prices are going through the roof. We're seeing more and more pellet and wood boilers being installed as a secondary source or a primary source. That boiler needs to be protected against return water protection because they can creosote up pretty badly, and you can have some issues with that. So let us know if we can help with that. We've got plenty of piping schematics and different ideas for you installing those. Another good thing to do on your systems is have a what I call a little workout program, and we've got a relay, and there's other relays, of course, on the market that have exercise programs built right into the board. And this is one of our new Z1 relay boards, one of our pump relay controls. And I don't know if you can see it in this picture here, but there's a little switch in there that you can toggle that would give you an exercise program. And basically what it's going to do is if the pump hasn't run for 72 hours, it'll start that pump and it'll just fire it and run it for 30 seconds here. All the pumps, you can see there's, we've got 6 different pumps in here. So whatever pump hasn't run for 72 hours, it'll fire that up and run it for 30 seconds. So during the downtime, during the summer, something like that, just to make sure that those pumps get moved a little bit so they don't have a tendency to seize. Some of these new pumps are only about 30, 40-watt pumps, so they don't have a lot of starting torque. So you want to make sure that if there's any dirt and debris or if you've got bad fluid quality, that you make sure that you spin that pump every now and then, keep it free, keep it moving so they don't seize up. So if you're installing these type of controls on your system, look for one that's got these different functions on it, like an exercise program, post-purge, and some other things too. This is another little device that we make. I don't know a lot of people aware of it. And basically, you can have a job occasionally that you get a chronic air problem where you go and you purge the air out, and they call you back a week or a month later saying, you know, it's noisy again. I can't sleep at night. I hear all this bubble and gurgling going on in my radiators when my heating system's on. You got to come back and get the air out and get this thing sorted out. Well, you can actually suck air into an air vent. This little float that's in there, if you've got a condition where you're pulling the pressure to a negative on this, air can actually come in this vent. And you're going to see this specifically on systems that have high head pumps that are pumping towards the expansion tank. So every time that circulator kicks on, there's a little droop or drop in pressure on the suction side of it. If you happen to have one of these vents in the system somewhere, it could be on a radiant manifold, it could be at the high point in an air handler. A lot of these vents are installed in systems for high point air elimination. They can actually allow air to come in. And so this is basically, you take this cap off and you screw this on, and it's a check valve is all it is really. And we call it an anti-vacuum cap. So you take that off and you screw this cap back on the top of it. And now what it'll do, it'll allow any air to come out of the system, but it won't let air get pulled into the system. Now, it's a Band-Aid of sorts. If you are getting air into a system, you should really find out what's causing that and fix that. You know, this treats the symptom. It doesn't really treat the problem, but it is a little handy part to have a couple in the glove box of your truck. So if you got a system where you don't have time to go back and change the piping or correct the problem, you can just put this on, at least solve the problem until you can get back at a later date and correct the cause of the problem. We do sell that as just a little standalone piece. It does fit a lot of different brands. This is a fairly common thread that you'll see from brand to brand on the top of this, so check that out if that's something you think might help you. Another cap along the same lines is this is called an AquaStop cap. You can buy this as a separate component. Some of our air vents come with this already installed, and basically what it is, it's got a cap with a bunch of these cellulose fiber discs in it. So as soon as these discs get wet, like this one I got here in a paper clip that I dipped into a cup of water, they swell up, and so you get a second level of protection. So in addition to have the float and the little needle valve that shuts off right underneath here, this gets you a second level protection. So if some dirt or debris gets stuck in this little stem that's in here that the float moves up and down to shut the air off, leaks through, now you've got the cap that'll catch it. So within about 2 to 3 seconds of these fiber discs getting wet, they'll swell up and shut this cap off. And then of course as they dry out, as the water goes away, they dry out and they can allow the air to come out again. So I would definitely put these on critical applications, like if you're going to put a radiant manifold up in somebody's closet or something where you don't want the water getting out in their floor. This is a good way to give you another level of protection. Again, it does fit a lot of different brands. It's a common thread. You can actually use these in conjunction with one another. You can put one of the hydroscopic caps or one of these aqua caps, I'm trying to say here, on top of the check valve. So now you got the check valve, the aqua cap, as well as the float valve in here. So you've got a 3-in-1 device there. Filters or Y strainers, I'm of the opinion every system out there should have some sort of filter device on it. For years we've used the Y strainer. Be aware that a Y strainer, this is sometimes called a cartridge type of filter, its limitations are the coarseness of the mesh in there as far as what it's going to filter out. But the other thing with the Y strainer, if you from day one, here's a brand new Y strainer put in the system, a 1-inch Y strainer, it's got a little bit of pressure drop going through it because, again, all the fluid's got to go across that screen as it flows through there. And the other thing to know about these, as they start plugging up, as they start doing their job and filtering out the dirt and debris in there, they're going to reduce the flow going through that. In fact, here at 70% plugged, you can see what it does to the pressure drop of that Y strainer. So if you are using this type of device, just go back and disassemble them, or at least put a valve in here that you can blow them down and flush them down, because you got to clean those out occasionally if they're doing their job. If you've got an old system that has a lot of dirt and rust, like a cast iron radiator system or an old iron pipe system, the strainer can protect it, but you've got to protect the strainer, so to speak. I think a better way of doing that is with a separator. We make a lot of different types of these, some with magnetic bands, but basically the difference is with a separator, you're causing the particles to fall down to the bottom where they're out of the fluid stream, so you're not plugging up the flow going through it. What do I got here? A couple more slides. So, checklist. Keep one of these mentally, or maybe even on your iPad or on your tablet or whatever you're using, or maybe even a paper version of that. But really what you want to look at is just look at the system. The first thing you want to do when you go into the job is, meet with the homeowner, just look everything over, take some pictures with your camera, do some documentation, and talk to the homeowners that, if there's problems that they've had since day one, maybe you can be the hero and correct some of those. Use all your senses, feeling pipes. A good way to tell if heat's going up to the upstairs levels, put your hand on the pipe that's going up there. Is it getting as hot as the pipe coming out of the boiler? If not, you could have an air blockage or something like that. By confirm, just make sure that all the equipment on there was sized properly, that it is running, the little spindicator gauges or little flow meters or something like that, to make sure all the pumps and zone valves are spinning and open properly. Different tests I talked about, combustion analyzing test, fluid quality test, document all that stuff, and then, of course, get paid. So what have I got? About 4 minutes left. Let me get through some of the housekeeping things, and then I'll see if Woody's had some questions that we can answer while we've got you all online still. Coming up next in October, Kevin Fried works at Caleffi. He's our tech support guy. If you've called with a tech support question directly to Caleffi in Milwaukee, you probably talk to Kevin. Great guy, smart engineer, knows his stuff. He's going to be doing a little presentation. He helps us a lot with product certifications when we have to get our valves, whether ASME or ASSI or whatever the certification might be. He's going to explain what all those mean. It might give you some help and some leverage if you're arguing with an inspector about the right certification or why you have to use a certain valve. He's going to try and clear up some of that nomenclature, what all that means. November 20th, we've been building a lab up at our location up in Milwaukee, and it's really nice. We can test a lot of different equipment. We've got some lab quality instrumentation. We've got some ultrasonic flow meter that's kind of fun to play with and watch. So we're going to try and do a live webinar from up there and show you some of the equipment, some of the testing that we do. We can test new equipment when we're developing new products, as well as products that gets returned to us. We can test it and see what's going on. December and January, I talked about this earlier. It's going to be a two-part one. Again, analyzing head loss on a hydronic system. This has to do a lot with pumps. We're going to look at, how do I tell what type of pump I need in the system if I don't think the right pump is in there currently, how I can do those calculations and analyze that, and then, of course, the circulator performance. All right, I got a circulator in there, supposedly moving 10 gallons a minute, 10 feet ahead. Where, in fact, is it working on? It's a pump curve. So we'll show you how to do all those calculations in a two-part series in December and January. The other thing I'm going to ask you there, we don't have a lot of scheduled for next year. We've got some guest hosts that are going to come on board and do some things for us, so we do have some things in mind. But let us know what's on your mind or what you think we should be talking about, or if you want to volunteer to come on and do a little presentation on something that's near and dear to your heart, certainly get a hold of us, and we'll get you slotted in there. If you stay online, at the end of this, there'll be a little survey. We're trying to get some information on press fittings this month, so there'll be a survey there, and of course you can click if you want the certificate. If for some reason you don't see that, or you don't get to that, or you don't have time and you still want a certificate, just send us an email. We'll make sure that you get this for you and the people that are viewing it in your office today. So that's available. A blog, we've got the Ask Caleffi blog going. Again, this is just little things that we talk about on a weekly basis, so sign up to get that. Kevin and I do most of the blogging there, but let us know what you think about that. Caleffi Excellence program, we kicked it off again in September. This is our second year doing this, and we switched it up quite a bit. It's going to be a monthly contest now, so what we're going to do is we're going to ask you, the attendees at the Coffee with Caleffi, to do the voting. So at the end of the month, we're going to show all the entries and say, just click on your little button and vote for who should be the winner there. The winner will get an iPad mini, and then the 12 monthly winners will be put into the drawing for a trip to Italy for two. So there'll be an annual winner as well as a monthly winner. So a little bit of an instant gratification instead of waiting for the quarterly results. Every month we're going to have contest giveaways there. So Coffee with Caleffi, Caleffi Excellence. Let's see what else I have here to cover. I think I talked about that a little bit earlier. Number 15 is on the streets right now. Sign up for those if you're not getting them. Let us know if you need some back issues. Other things that you can keep in touch with, Facebook. We've got the YouTube channel now, so a lot of different 1 to 3 minute videos, little quickies on there, and different things that are going on at the trade shows and the industry as we travel around. So keep in touch with us there. All right, I think I hit it pretty close there. What do you got? Anything there for questions, or?
Yeah, I have a few here. We could a little time for it. Right off the bat, back on the filling, back in the filling area, you were talking about filling. Is softened water okay for filling?
That one I'm kind of torn on that. I think it's a lesser of two evils with softened water. Some people say there could be a little salt residue in the water when it goes through a salt type of backwash softener. I would say the lesser of two evils, if you got water that's 30, 40, 50 grains hard, certainly the soft water I think would be a better solution than having water with that type of grains of hardness in it. Again, the very best water would be a deionized or demineralized where it doesn't use a sodium for the backwash, but I think in some cases the soft water would be better than the hard water. But, I'd probably defer to the manufacturer on that and get their take on it. I know they've got a hardness. I think the one I looked at yesterday from Heat Transfer Products said under 10 grains hardness. So That's what I would say on that.
Okay. On the fill valves, again, boiler fill valves, on or off?
Yeah, and I don't think that controversy is ever going to go away. It's kind of like a Ford or a Chevy issue, which one's better. The two, concerns there, if you leave a fill valve on and there is a break or a leak or freeze or something in the house, you're going to dump a lot of water into that house possibly until somebody comes back and finds it. So that's the one biggest downside of leaving the fill valve on. It doesn't know if there's a leak in the system. Now, I know there are some valves out there now that you can get on your domestic water lines coming into a building that can sense and can shut off a water main if they think there's a break in the pipe. I don't know if they do that with a flow switch. I've never used one personally, but that would be another thing that you can consider if you're going to leave your fill valve on, is put one of those high flow cutoff valves on it. Now, if you leave the valve off, and to me this can be a bigger problem, is most of the new ModCon boilers have pressure switches in them, and they've got to have about 8 to 10 pounds of pressure on them, or they'll go into lockout issues. So if you've got a job with an air purger and that system runs and it's burped out a little bit of air, and now the pressure's dropped down a little bit because the fill valve couldn't refill, you could have a no-heat lockout. So I don't know which is, you're going to have to decide yourself if you're willing to gamble on a potential having a leak causing some damage from water, or if you want to go back to a job because you've got a low water trip out because you burped some air out of it and your fill valve couldn't maintain that. A compromise might be leave the fill valve on for the first couple weeks of a job, just to make sure all the air is burped out, that you've got water in the system, and then go back and shut it off. What I could do with our Caleffi valve is we've got a shutoff built into the bottom of that little gray knob on the bottom. You screw that all the way in and maybe just crack it open a half a turn. So it would allow a small seep of water going through it to fill any kind of air that burped out of the system, but you're not going to get 3.5 or 4 gallons a minute through it if a pipe breaks or comes unsoldered or something like that. So I don't have the best answer for that, but those are the my two thoughts on it.
Okay, and then there was just one other kind of procedural thing. We were asked to please start at noon on Thursday. I think we were a week early this time, weren't we?
I didn't catch that one.
Basically, the question is that these are at noon on Thursday. They're once a month and usually the last Thursday of the month, but I think we pushed it up 1 week because of some other conflicts, right?
Yeah. Mm-hmm.
So you can look for these being the last Thursday in the last week of every month.
Yeah, I mean, we try and do it the third or last Thursday of the month. It just depends. Sometimes it conflicts with a trade show or something else.
Yeah.
But we try and keep them all about the same. Sometimes we skip a little bit around Christmas or New Year's, knowing that people have a lot going on there. So sometimes you might see a hole in our schedule around December. Or December we've got one, but January maybe. But we try and get something put together every month for you.
Okay, well, that's about it.
All right. Well, again, thanks, everybody, for tuning in. Hi to Nathan and some of my friends. A lot of people I know online today, and some new faces, too. And I appreciate all of you tuning in. And if there's things that you can teach me, I'm always open to learn some new things, too. You can teach this old dog new tricks, so I'd love to hear from you, whatever you've got to say. And we'll see you next month with Kevin. Thanks, everybody.